Alright, this is 2.3 for 6th grade. This is page 72 in your book. So if you'd open up to page 72, let's get some notes started here. We have scale drawings, and scale drawings are defined on page 72, about in the middle. It says a scale drawing takes the original object and it is a drawing that is the same original object, but it is a different size. Okay, so like if you were an architect and you wanted to have a scale drawing of a building you wanted to build, you wouldn't make the drawing of the actual size, you would scale it down smaller, or even make a model that would be smaller. I know sometimes you make models and it's that you can't obviously have a model of a car that's the exact same car. It'd be kind of funny pushing that around if you did. The scale tells us how the dimensions are. The dimensions are the scale of it, how the dimensions are related. For example, is it half the size? Is it 2 times bigger? ... So we'll do a couple of those to understand as we go through. So we start to look at example 1. It says find the actual length that corresponds to 1 inch, 2 inches, and 3 inches on the scale drawing. How long is the actual canoe? So one thing that's important is to look at the scale. This down here is the scale. It is telling us that 1 inch equals 5 feet. So every 1 inch is going to be equal to 5 feet in the real canoe. So from here to here is 1 inch, which is equal to 5 feet. Here to here, that's another 5 feet. And here to here is another 5 feet. So that canoe is going to be 15 feet because we had 3 inches. And what I like to do is I write the scale like this: 1 inch equals 5 feet. And then I count how many inches did I have. 3 inches equals how many feet. So I look at the relationship from the top to the bottom. What do you do to 1 to get 3? You take it times 3. So what are we going to, if we're doing a scale drawing, we do the same over here. What are we going to take times 5 to get the missing? We'll take it times 3, and the missing dimension then is 15. So this is a very important skill, a very important way to understand how to solve it. So let's see how the book went through it. They made a table of the feet, the 5, 10, 15, just like we did. And then they have the 15 feet. So they did a little different than what I did. So let's see example 2. A catalog pictures a necklace smaller than its actual size. The scale is 3 centimeters to 8 centimeters. So 3 centimeters to 8 centimeters. The length of the necklace in the catalog is 18 centimeters. How long is the actual necklace? So what we know as far as this one goes is this is the necklace right here. This is the necklace, and this to its actual size. So this is the picture in this one is the picture in the catalog, and this is the actual size. So if the catalog's is 18 centimeters, how long will the real one be? Right here. So every 3 centimeters is equal to 8 centimeters. So you look, what do you do to 3 to get 18? You take it times 6. So then we treat both sides equally. So we take this times 6. So that one would be 48. So the answer would be D. So let's see how they explained it. Find the relationship between the known length on the scale, which is what we did. You'll see right there, that's the 3 to the 18. What's the relationship? And it's times 6. So then we times the other side times 6, and we ended up with 48. It's kind of tricky, but they're kind of fun once you know how to write them. So we'll keep doing some examples here. You are building a model boat with a scale of 1 inches equals 2 feet. So as soon as I see that, I write it. 1 inch equals 2 feet. The actual boat is 18 feet long. How long should you make your model? So they're giving me 18 feet. So I know that feet and feet go together. and I'm missing this one, which is the inches. So I look at the two that I know that are on top of each other, and I think, what do I do to 2 to get 18? I take it times 9. So then I do the same thing over here. If I multiply it times 9, 1 times 9 is 9 inches. So there's the 1 to the 2. There they are, taking it times 9, and then you get the 9 inches like what we got. Okay, so let's do some guided practice. What if? Suppose the scale in example 1 is 1 inch to 6 feet. What would the actual canoe be? So it's 1 inch equals 6 feet. Remember, the picture of the canoe had 3 inches in it, so how many feet would that be? So I look at the two that I stacked on top of each other that I know. What do you do to 1 to get 3? Times it by 3. So then you're going to do the same thing over here to the 6, times it by 3. Then that canoe would be 18 feet. So they're doing the same thing that they did before, but I kind of like my little picture there. Suppose the necklace described in example 2 is pictured as 21 centimeters long. How long is the actual necklace? So we go back to the 3 centimeters equals 8 centimeters. And they said it's 21 now. So what would this one be? So, and here's, it's important to, easy to know your facts. 3 times 7 is 21. So over here I would take this times 7. So it would be 56. And in example 3 it says, suppose the scale in example 3 is 1 inch equals 3 feet. And I'm going to have to look back at example 3. What was example 3? Oh, that was the model. So if the boat was 18 feet long, what do you do to 3 to get 18? You take it times 6. 1 times 6 in this case would be 6 inches. So that boat would be, the model, excuse me, should be 6 inches long. Boy, that'd be a small boat, wouldn't it, if it was 6 inches long. So there's some scale drawings. Make sure that you, if you need to write those little things that we did to practice, to stack them on top of each other and see the relationship. And this is it for 2.3. We'll see you on 2.4.